On the bench today is the Pentax K1000. I've got the top removed, the mirror box out, and I'm finally getting to the shutter. I'm going to give it a full service today, which means disassembling most of the critical timing mechanisms, cleaning them up, then reassembling and lubricating where necessary. Before I get started, I want to do a quick overview of the basic operation of the shutter, because I think it will make the rest of the repair a lot easier to follow. The K1000 uses a horizontal focal plane shutter, which just means that the light blocking elements are located near the focal plane rather than in the lens, and they travel left to right instead of top to bottom. Each curtain is mounted on a pair of spindles that suspend it in front of the film plane. On the right side of the camera are the spring-loaded rollers that power the shutter. They provide the force that pulls the curtains across the frame. The shafts on the other side of the camera are connected to the winding gears and to all of the various timing mechanisms that control the duration of the exposure. When the advance lever is actuated, the curtains are pulled across the camera into the charged position. Firing the shutter releases the first curtain, exposing the film to light. Then, after a specified amount of time has elapsed, the second curtain is released, covering the film. In most mechanical cameras, like the K1000, there are separate mechanisms that time the slower speeds and the higher speeds. And I'm going to start on the slow end. This thing is essentially a collection of gears that slows down the shutter through raw mechanical inefficiency, friction, and inertia. If I get in close here, you can see the gear train spinning as the second curtain is trying to push its way through. The silver arm at the top there connects the closing curtain gearing to the slow speed mechanism. If the shutter speed is set to 1 second, it has to push that slotted lever through its entire length of travel before the second curtain is released. If I change it to something faster, like 1/8 of a second, it only has to push it part of the way before releasing. Even faster speeds, like 1/15th and 1/30th of a second, are achieved by disengaging the pallet on the right side here. That's where most of the resistance comes from. When the silver linkage is pushed, the pallet moves away from the star wheel and allows the train of gears to spin much faster. The delay rod and the pallet rod act as relay mechanisms, transferring settings from the shutter speed selector down to the governor. There are cams on the underside of the shutter speed knob that push the rods into different positions to achieve the various shutter speeds. I'll show these later on in the disassembly. Okay, taking the slow speed mechanism out is pretty easy. There are just a couple screws underneath the bottom plate that hold it in place. Here's a closer look at the action of the gears. You can see the pallet interacting with the star wheel and how the linkage disengages it. That is going to spend some time in a bath of isopropyl alcohol to soften up any old gunk that has settled in. And then I'm going to use an ultrasonic cleaner to get a nice deep clean on all the intricate parts. It is possible to disassemble and clean pieces individually, but it's not necessary unless there are some serious problems like rust or corrosion. A good soak and shake is all that's needed for general cleaning. I currently have the advance lever installed for easier testing of the camera, but I'm not going to have that luxury going forward. In order to access the shutter, I need to remove most of the winding mechanism first, and that starts with the advance lever. Underneath is a coiled spring that returns the advance lever after cocking. At this point, it's kind of loosely hooked onto itself to keep it from unwinding, and if I carefully remove it, I can place a pin through a hole in the mounting plate, and that will keep it all together. Or I can let it violently unwind, flinging parts all over my desk, which is the method I've chosen here. It's okay. It just means I have to wind it back up when I reinstall. Here are the little spring-loaded pawls that give the wind driver its ratcheting action. You can see the grease from the central axis has started to creep out over time and is gumming up the movement a little bit. I'm popping the film door right now to remove some of the tension from the frame counting mechanism. It sits underneath the next large plate that I need to remove, and it helps to make everything a little less jumpy. I just removed the little lever that tells the user whether or not the shutter is cocked. It swings back and forth, showing either red or black through a little window in the top plate. And this nut has a spring wrapped around it that acts as the pusher for that lever. This gear on the bottom is connected to the frame dial on the top of the camera. Basically, each time the camera is wound, it advances this gear by 1 tooth, which corresponds to 1 count on the frame dial. Here's a quick look at the auto reset function for the frame counter. When the film door is opened, the gear on the left moves away from the counter gear, which then springs back to 0 and is ready to count the new roll of film. These are all the parts that are under tension right here, so I need to keep a finger on them as I pop them loose, otherwise they may go flying. Whenever I encounter a stack of pieces like this on a pivot, I try to place them on my parts tray in the order of disassembly. That way I know how it goes back together without having to do any serious figuring. Of course, understanding how the mechanism functions is a more surefire way to get it reassembled correctly, especially if something were to happen to my carefully arranged parts tray, but good disassembly habits can save my brain for the more critical tasks. Okay, moving on to the main speed selector plate. This piece pretty much ties all of the timing components together. Once this is removed, there are going to be a bunch of loose parts, and the shutter won't fire in the normal automatic way it has been. Earlier I mentioned some cams that controlled the delay rod for the slow speeds, and here they are. You can see as I turn the shutter dial, the silver lever moves in and out. The hole at the end of the lever is where the delay rod connects and gets positioned based on the shutter speed setting. This red lacquered screw on the side is the adjustment point for the slow speeds, which I may use later on to tune up the shutter. Pallet and delay rods are just hanging out unsupported now, so I need to remove those. The pallet rod has a small brass bushing on the bottom, which easily slips off. Need to make sure I don't lose that. I can do some manual firing of the shutter here to help show the curtain releases a little more clearly. I'm going to push the transport latch with my tweezers, and the pick will get the first curtain latch. Now if I push out this lever, I can release the second curtain. It's difficult to see, but the second curtain gear is directly beneath the first curtain gear, and the latch that I'm releasing is tucked under there as well. One more time, the first curtain is released, and the high-speed cam releases the second curtain. What is the high-speed cam? Well, that is the part that governs the fastest speeds of the shutter. It sits right here on top of the first curtain wind gear. When the shutter is fired, the first curtain is released, and this gear spins counterclockwise. When it spins, the high-speed cam pushes the lever I was showing in the previous segment. When it pushes it out far enough, the second curtain is released and it travels across the frame, completing the exposure. The position of the cam controls how much the second curtain lags the first curtain. This hole in the shutter selector that the high-speed cam rides in is eccentric. It's not centered on the axis of the knob. So as the knob is turned to different speeds, the cam moves ever so slightly in or out. At 1/1000th of a second, the cam is pushed out to the edge, and the second curtain releases almost immediately after the first, making a slit just a few millimeters wide between the curtains. At 1/125th of a second, the cam sits further towards the center, and the first curtain travels most of the way across the frame before the second is released. Okay, I have a few more mechanisms I need to remove before I can clean and lubricate the shutter. First is the stack of latches. The second curtain latch is here, but there's also a latch for bulb mode. In bulb mode, it's not the high-speed cam that starts the second curtain, but rather the shutter button being released. So there's a feeler that sticks out onto the tapered section of the release shaft. And when the shaft moves up, it pushes the latch and sends the second curtain. Next is the curtain brake, which is held by a rather stiff spring. Definitely want to remove that tension before loosening the screw. The curtain brake does two things. First, it applies a slightly more gradual deceleration instead of letting the curtain slam into the end stop. And second, it catches the curtain and prevents it from bouncing back into the frame, which can cause weird exposure anomalies in your photos. The plate that all this stuff is mounted to is called the stop plate. The silver nub on the gear hits the stop plate at the end of the curtain travel, but also at the end of winding. So basically it defines the starting and stopping points for winding and unwinding of the shutter. This next set of gears, called the transport gears, are very important for understanding the release sequence in the K1000. Their role is to connect the winding mechanism of the camera to the shutter curtains. So when the advance lever is used, it not only moves the film, but also pulls the curtains back to their starting positions. But the curtains can't fly across the film opening if they're connected to the winding gears. So there needs to be a way to temporarily decouple them before an exposure. And that's what this little pin does. When the pin is up, the two gears move together. The bottom gear can push the top gear, which in turn charges the shutter. When the pin is pushed down, the stepped profile allows the upper gear to pass over top and move independently of the lower gear. So during winding, the two gears move together, and during an exposure, only the top gear spins. The last pieces that I want to take out for cleaning are the wind gears, but I need to be able to put them back in exactly the same positions as they're currently installed. I'm using some red lacquer, aka nail polish, to mark where the gears mesh with the current pinions. Changing the position of the gears could result in curtain edges sitting in the frame, or a gap between the curtains when I wind them. Even an increment of one tooth could make it impossible to properly time the shutter at high speeds. All of this was properly calibrated in the factory, and the best way to maintain that calibration is to put it back exactly as it was. But honestly, I would do it a little differently next time. When I ran the brush across the interface, some of the liquid ran down onto the teeth, and I had to do quite a bit of cleanup to get it off. You really don't want lacquer on the teeth of your smooth-running shutter gears. I think 2 alignment dots, one on the face of each gear, would do the job just as well. The first wind gear is held on from the bottom. If you recall the first curtain latch that I've mentioned previously, that is screwed on the shaft of the wind gear. First, I have to remove that, and then the wind gear can come off the top. The last piece I'll be removing is the second curtain wind gear, which has been hiding underneath the other gear this whole time. The tolerances on the shaft are very precise, so it can be tricky to get loose. It has to come off at a very straight angle. And I also have to temporarily mesh it with this upper pinion so it can slip by. There we go. Looking more closely at this gear, you can see the latching surfaces that interact with the other mechanisms. The big lug on top is the second curtain latch, used for the high-speed release. And the sloped one on the bottom is what pushes the delay rod out of the way for the slow-speed release. So why do all this disassembly? Or more specifically, why do this much disassembly? Why stop here? I don't feel like I have a great answer for this. My reasoning to go to this point was to get access to most of the important bearing surfaces in the shutter, so I can lubricate them and, more importantly, clean them. The only remaining places I can't clean are the bearing surfaces of the curtain rollers and the pinion shafts. To do that, I would need to completely remove the curtains from the camera, which I feel provides marginal gain for a lot of extra work. If I had identified significant problems with the curtain travel in my initial evaluation, I'd be willing to do it, but the shutter times were really pretty good. Anyway, all that said, the balance between disassembly effort and performance gained is something I'm constantly negotiating and evaluating. It changes from camera to camera and honestly from season to season. With all of the bearing surfaces thoroughly clean, I can move on to lubrication and reassembly. I'm going to be using nye oil for all of the fast-moving components of the shutter. It's a highly refined mineral oil with properties well suited for these types of mechanisms. I'll start with the shutter rods on the wind side of the camera. For these, the bearing surfaces are where they pass through the mounting plates. This is where they spin. I'm using a pretty small oiler, but it can still be tricky work getting the oil to go exactly where I want it to. On the other side, the rods are fixed in place, and the rollers spin on the shafts, so that's where the lubrication needs to go. There's a little bit of play in the rollers, so I can kind of slide them back and forth to get access to the shaft. In addition to the roller bearings, I also need to oil any parts that are moving rapidly during an exposure. Basically anything that could affect the speed of the curtains. For example, right now I'm oiling the wind gears because they are directly connected to the curtain pinion shafts. And as I reinstall the wind gear, I need to set the proper timing based on the markings I made earlier. In addition to the shutter oil, I also need to lubricate all of the latching points between mechanisms. On this gear, that includes the high-speed and slow-speed latches I mentioned a couple minutes ago. This is the same stuff I used for the latches on the mirror box, a medium-weight moly grease. I'm just cleaning off more old grease from the first curtain latch underneath here, and then I'll apply some to the newly cleaned surfaces. Now, getting the latch back on the spindle of the wind gear is a little tricky. I have to push the wind gear up a bit to make enough room to slip the latch on, but this pushes the wind gear out of engagement with the pinion. So after the latch is on, but before I screw it in place, I need to double check that the gears are still meshed at the correct point. Yeah, looks good. The latch reinstalled, the wind gears are now fixed in place, and I can remove the timing marks I made with the lacquer. This post here is not part of the shutter mechanism, but rather holds one of the idler gears for the winder. That makes it a high-friction, low-speed interface, and the service manual recommends applying grease for the lubrication. I'll be a little more liberal in the application than I am with the latching points, but I still don't want grease squirting out the ends. Next is the curtain brake. This is attached with a shoulder screw, and once the screw is fully tight, the brake should still be free to swing. The spring will provide the necessary braking force. On top of the stop plate here is an interesting little contraption. It's a small plastic tube with a piece of string running through it. It's an oiler. It's meant to provide a slow, steady supply of lubrication to the curtain brake. One end of the tube can be accessed from the back of the camera by removing the top cover, so it can be periodically refilled. When oil is added to the tube, the string acts as a wick, carrying it to the other end where it gets deposited on the stop of the wind gear. What I don't quite understand is why this type of lubrication was necessary at this particular point instead of the standard latching grease, which is used literally everywhere else. What's so special about this mechanism? I don't have a good answer yet. The next piece to go in will be the upper transport gear, but first I need to get the camera into the proper state. The shutter curtains need to be wound to their starting positions, and the lower transport gear needs to be turned until the pin seat is at the 6 o'clock position. The latch underneath the gear should find a notch holding it in place. Now, based on my previous criteria, the upper transport gear should also get oiled. It's a fast-moving part that is in action during the exposure. But the service manual just recommends cleaning it and leaving it dry. Apparently, oiling the interface can lead to erratic movement in the shutter. I'm okay just taking their word for it. Here are the high speed and bulb levers. They'll get cleaned and re-greased. This one can take a little extra negotiation to get installed. I have to get both levers aligned to the post. And then there's a bias spring that needs to get hooked on here. And make sure the bulb lever goes on the correct side of the release shaft. Yeah, there's a lot to keep track of. The nut has another bias spring, which needs to get hooked. But it looks like everything has found its home. The high-speed cam needs a good clean, and then it will receive both forms of lubrication. The edge gets greased to prevent wear and to make sure the curtain latch can slide smoothly. And then the spindle will get oiled to facilitate that high-speed spinning. The pallet and delay rods are a bit of a balancing act, literally. I get them seated in their holes in the bottom of the camera, but then they just kind of stand there swaying back and forth while I get the other bits in place. It's easy to accidentally knock them over and have to reinstall. And finally, the mama piece, the speed selector plate that holds everything together. The high-speed cam, the delay rod, and the pallet rod all need to be inserted into this thing simultaneously. And with the rods wobbling all over, it can get pretty fiddly. It usually takes me a couple of attempts, but edited SAM is much more coordinated than real-life SAM. See? Easy peasy. With the high-speed mechanism now back together, I can fetch the slow speed governor from the ultrasonic cleaner. I did that bit off camera, but I can give a quick summary. After several hours soak in the isopropyl alcohol, I put the part in the ultrasonic using a 50-50 mix of simple green and water as the fluid. I use the aluminum safe or the aircraft version of simple green because occasionally I will clean aluminum parts. After that, I rinsed it under running water to remove all the soapy residue, and then one last dunk in the IPA to displace all the water. I don't like letting water dry on parts because I'm afraid it will leave behind deposits because tap water is dirty, or even initiate some rust. But IPA doesn't leave anything behind. Some camera makers specify that their slow speed governor should run dry, but Pentax recommends lubrication. I'll apply some Nye oil, actuate the gears to draw it into the pivots, and then clean up any excess with some Rodico. Alright, let's get this back in the camera and I can do a final check of the shutter. So I'll throw this on my camera tester to make sure everything is roughly in the ballpark, that I didn't make any gross reassembly errors, but I'm not going to do the final tuning of the shutter until the very end. But this is sounding much better than it was before. I hope you enjoyed this little tour of the Pentax K1000 shutter, and I'll see you next time.